You know how we talk all the time about cleaning up pollution in the environment? Well, what if we could do that, but for our own bodies? A really fascinating new theoretical paper has just laid out a radical idea to do exactly that. It's a tiny, ingestible pill designed not just to treat us, but to actively clean us from the inside out. Let's break down how this totally futuristic concept is supposed to work.
Okay, so to really get this, we first need to wrap our heads around the two different problems it's trying to solve. Now, at first glance, they might seem totally unrelated, but the real genius here is how this concept connects them.
The paper frames this whole thing perfectly. It looks at this constant, low-level exposure we all have to stuff in our environment, like microplastics, and it links that to another huge modern concern, the way our immune systems sometimes get, well, a little dysregulated. So on one side, you have these tiny foreign particles from our world ending up inside our gut. And on the other side, you have our immune systems, which can sometimes get their signals crossed and overreact, leading to things like inflammation or allergies. This concept asks a really powerful question. What if these two problems could actually have one connected solution? So, what's the big idea? Well, get ready for it. It's called the Dust Biome Magneto-Triboelectric Capsule. I know, right? That's a total mouthful. So let's just call it the Capture and Cure pill. Much easier. You can think of it as a single device that acts like both a janitor and a personal trainer for your gut. The core idea here is a pill that takes 3 different technologies we already know about and combines them into one incredibly sophisticated package. It's built to do 2 jobs at the exact same time, physically remove the junk we don't want, while biologically re-educating our immune system.
The way this thing is built is just so clever. Think of it like a high-tech onion with 3 layers, and each layer has a very specific job. The outer shell, that's the plastic catcher. The middle coat, that's the part that talks to your immune cells. And that inner core, that's just a slow release mechanism to make sure this whole process happens gradually over 1 or 2 days as it travels through your system.
Okay, so let's dig into that first function, the capture. How in the world do you get tiny plastic particles to stick to a pill? Well, it's all about pure physics. The design uses this awesome 1-2 punch of magnetism and good old-fashioned static electricity. This 2-pronged attack is what makes it so smart. First, the shell is infused with iron oxide, which basically turns it into a tiny magnet to attract and clump particles together. But then, it also has this special microtexture. As the pill tumbles through your gut, that texture builds up a static charge from friction. It literally becomes a tiny piece of static cling wrap for microplastics. How cool is that? So while that outer shell is busy playing janitor and cleaning house, the inner layers are working on a completely different job, immune modulation. This is the cure part of the capture and cure idea, and it uses something called postbiotics. Now, instead of using live bacteria, which can be a little bit risky, this concept uses postbiotics. You can think of them as the harmless, non-living ghosts of beneficial microbes. They're just fragments that act like little training dummies for your immune system, gently nudging it toward a more tolerant, balanced state. And it's all released slowly over time.
I know. This all sounds like it's straight out of science fiction. So how could something this complex ever actually become real? Well, the paper doesn't just throw the idea out there. It lays out a really careful, safety-first roadmap to get from concept to reality. This is the standard, rigorous scientific playbook, which is exactly what you want to see. You'd start with computer models, then move to lab tests in a dish, then to animal studies. And only after passing every single one of those safety and effectiveness checks would you even begin to think about human trials. For an ingestible device like this, that step-by-step caution is absolutely non-negotiable.
But here's where the plan gets really clever. The authors recognize that building an all-in-one super pill is a massive challenge. So they came up with this brilliant intermediate step. Don't build the combo pill right away. Instead, split it in 2 and prove that each half works on its own first. So the strategy is to develop 2 separate pills. You'd have Capsule A, the therapeutic one, which would be developed as a drug or biologic. And then you'd have Capsule B, the capture device, which would be treated as a medical device. This makes the testing, the manufacturing, and the whole regulatory process so much simpler. You validate each piece of the puzzle independently before you ever try to put them together. And this is a super critical point. If you're going to make a pill to remove plastic pollution from the body, you better make sure the pill itself doesn't become pollution, right? So the design actually includes an end-of-life plan. The idea is to have a magnetic trap for your toilet to catch the capsule, and then an enzyme pouch to safely break it all down. The ultimate goal? A zero net plastic footprint.
And it's so important to remember what the author says here. This is not a product announcement. It's a theoretical framework. It's a detailed blueprint that's been laid out in the open for other scientists and engineers to build on, to test, and to refine. It's basically an open invitation to innovate. Which really leaves us with this fascinating thought to chew on. We usually think of medicine as fixing our biology, fighting an infection, correcting an imbalance. But what if the next frontier of medicine is also about fixing our internal environment, about actively cleaning out the microscopic pollution of the modern world from inside of us? That is a truly powerful idea.